Hello, everybody. My name is Mirko Novakovic. I am co-founder and CEO of Zero, and welcome to Code Red. Code, because we are talking about code, and Red stands for requests, errors, and duration, the core metrics of observability. On this podcast, you will hear from leaders around our industry about what they are building, what's next in observability, and what you can do today to avoid your next outage. Hi, everyone. Today, my guest is Jad Naous. Jad is the founder and CEO of Grepr. Previously, he was Chief Product Officer at Imply, the company behind Apache Druid, where he scaled the engineering organization and helped transition the business into a SaaS company with Polaris. Before that, he was an early architect at AppDynamics, where he helped build 3 of the 6 products still sold today, and later an investor at Andreessen Horowitz focused on infrastructure and data. Excited to have you here, Jad.
Hey, thanks, Mirko. It's been it's a long time coming.
Yeah, absolutely. And I always start with the first question. What was your biggest Code Red moment?
I thought a lot about it. I couldn't think of one moment when it was, this is the one, but I could think of a lot of them. And to me, it's kind of like the sum of all of it is always, we should have paid attention to this. Oh, we should have paid attention to that. Oh, we cut a corner here or somewhere and we forgot that we actually cut that corner, and then we rolled out into production, and now it came back to bite us. I mean, it's always, rolling out into production is always kind of a dice throw. And very often we find ourselves in situations where, like, code red, everything needs to go, everybody on board to go and fix it. And, there's no one moment when I was like, oh, this is it. It's always been, it's happened many times.
Code Red all the time.
Not all the time, but it's happened a few times where it's like, you're like, okay, we've messed up here. We got to go back and fix it.
Yeah, absolutely. I mean, I always say it's always coming from a change, right? Every Code Red starts with a change, and then you have to figure out what it was and then roll it back.
Yeah, it's actually like, for us, it's the issues kind of come from various situations where it's not that we made a change. As a startup, you're kind of always running forward and trying to move things faster and kind of get things deployed. And it's always, okay, well, in order to get this customer working or this deployment working, well, this is what we need right now. And we blow past those needs of that time. And we haven't actually taken steps to make sure that when that happens, then, we go and set up something new, or kind of there's a configuration change that we need to do in order to scale out more. It's always kind of these situations where it's not just a change in the code, but it's also a change in the environment that we find is the most problematic.
Yeah, and let's talk about AppDynamics before we start with Grepr, because I was an early reseller when it was like a few people, right? Jyoti, Buster, and a few others. And you were an early architect. And AppDynamics is still, if I look back on the 25-year history of APM observability, is still one of my favorite tools, to be honest. I think the UX was pretty good, a lot of interesting, innovative concept. So what were the 3 products you were involved?
I started on the business, what became later the business IQ team, where the goal was to try to collect all the data and figure out a way so that you could do business analytics on top of it. So basically, if you were able to collect anything from anywhere inside your code and store it in an analytical store, what are all the things that you can enable? It's odd that not more people or not more companies today are kind of focused on doing this kind of thing, where you would use operational data for business intelligence. But that's basically what that product initially was. And then after that, I worked on infrastructure monitoring, where we released our first infrastructure monitoring product. And then I worked on SAP monitoring, which was, given your German roots, this is...
But the business IQ, I have to say that also at Instana, I was always pretty bullish around doing business analytics on top of observability data, but I also never really did it. I don't know why, but I'm still bullish. I still agree that, think about it, right? You have all the parameters of business inside of a trace and in logs. Yeah, there's so much, and it's the real data, right? It's the reality. So you could do a lot of stuff on top of it, but nobody really does it. Yes.
Yeah, and I think it's just the persona and the people who are actually involved in what you actually need to do in order to get to a point where you can do this. And AppDynamics only really could do it after they were able to win the APM product. And so it's always been an add-on to APM as opposed to the primary thing. And so in order to get there, you kind of have to get to a point where as a company, you've got control over the APM market, and you have a roadmap that allows you to stay ahead of the competition, continue to deliver things that are new there, because that's ultimately the primary use case. But then on top of that, layer in business IQ as a separate unit and capability. So I'd assume that that's probably why you weren't able to get to it in Instana, because you were a startup and you needed to actually solve the primary problem really well.
Yeah, exactly. We never really got there, to be honest. But with AI and LLMs, I could even see it working better and easier, right? Just use an agent on top and try to figure it out automatically, right? If you look at the data, you can probably derive just from naming conventions and these things, you can derive a lot of the business data and flows from the data probably automatically. I don't know, but that's something I could see working pretty well.
Yeah, potentially you could maybe try to figure out that information. The biggest problem that I see with trying to apply BI or AI on that on kind of operational data is just the volume of data that exists that's required to deal with it. And it's just hard to kind of just slap AI on top of operational data and say, yeah, you know what, go ham at it. It's
Figure it out.
Yeah, exactly. You could, I mean, the way to do it is kind of similar to what you guys are doing and how you're thinking about it, and be able to use it more as a co-pilot search tool and a capability that allows you to connect the dots, as opposed to really trying to have a holistic view of everything that's going on in your environment.
Yeah, talking about a lot of data, right? I think that's one of the issues of observability that you try to tackle, right? We essentially also at Dash0 say, we say at the moment, observability is broken, right? It's just too much data that results in too high cost, right? Because you pay for a lot of data to be really honest, right? In observability, you collect a lot of data that you will never look at. That's more or less garbage, right?
It's insurance. It's insurance.
It's insurance, yeah. But it's very expensive in a lot of cases. So how did you come up with the idea to tackle that problem?
Before starting this company, I was at a company called Imply, which is the company behind Apache Druid. It's a very similar database to ClickHouse. And there we worked a lot with streaming data because it was real time. So people would stream data and they wanted real time updates. They wanted to understand what's actually happening in their business. And a lot of people used it for observability as well. And then after I left Imply, I started looking at what people have been doing in observability in terms of data stores and getting insight and so on. And it seemed like the architectures were broken. It was still doing things that are very similar to the days of AppDynamics, where you just collect all the data and you stick it into a database, and then you build your features on top of that database. And that kind of limits you in terms of what you can do with that data and what you can do with that database, because that database has to both serve the data in real time to the customer, but also deliver on kind of insights and features and capabilities that are needed to deliver those things. And with the explosion of microservices over the past 20 years, and just how trained engineers have become to just deploying observability and the new features and capabilities and everything that you can actually now with observability, the volume of that data has just exploded, while the value of any unit of data, if you will, has tremendously gone down. And so when I looked at this space and I saw what people have been doing in the real-time analytics space, where they were thinking about, well, how do I figure out what data is valuable, what data should be in a hot store, what data should be in a cold store, and then figure out how to query that data according to its need. None of that actually existed in observability. And then when you start to think about, okay, well, let's say we want to build autonomous operations in the future. We want to enable a single engineer to manage an entire data center of applications and systems. What do we actually need to get there? So in order to get there, you need to be able to deliver high signal, low noise data to an AI or an agent that can start understanding what's actually happening in the environment. Is there something wrong? Are there things happening the way that they're supposed to, and then be able to plan and remediate around that. But the biggest problem remains, which is that the volume of data is just enormous. And so If we were able to extract signal out of data and compress it in the stream, or understand what are the insights in the data immediately as the data is passing through, then we can, excuse my French, but kill two birds with one stone. So we would be able to reduce the volume of that data and compress it and put really just the low noise, high signal data into a hot store, put all the raw data into a cold, cheap store, and then be able to deliver insights, that compressed data, into an agent that can then monitor it and understand when are things going awry, when are there anomalies in the data, and be able to start a troubleshooting process immediately in real time as the data is passing through. And so ultimately, that's the vision of Grepr and what we've been building towards. We built out that initial piece where we could compress that data and reduce it as it's going to the hot stores. And we've seen reductions of over 95% in some cases in terms of the volume going downstream. And now we're starting to build out that second piece, which allows us to start monitoring the infrastructure in real time and understanding what is actually happening in real time based on that compressed data, and then take real-time actions to prevent incidents from happening in the first place.
Overall, you have a component, I would say, the category is called observability pipelines, something like Cribble, and we can discuss how you differ from that. But essentially, you put it in front of your observability tool, say Datadog, and you will reduce the data that is actually sent and stored in Datadog by 90% because you only send the really relevant data to Datadog and you keep the raw data in a cheaper
Iceberg.
storage like S3 or something, right?
Yeah.
That's how it works. So you're essentially a tool like the proxy or something in between where you send your data to, and then it's routed to Datadog, but it's just a fraction of what you would normally have in Datadog, and so you also pay a fraction of the cost.
Right. So that's the bottom layer, and now we're starting to build out the layers on top of that. Correct.
And that layer would essentially take part of the functionality of Datadog. So like figuring out when an incident happens or these things, or what does it do?
Yeah, eventually, this is kind of what we can do now, and we're starting to see people do it, where we have a streaming SQL built into the pipeline. So you could write SQL statements that can trigger alerts or can convert logs to metrics or combine events with logs, with metrics, with traces to start understanding when is there an anomaly or not, and then fire off alerts so that you don't have to feed all the data downstream just in order to get alerts. So that's part of what we're building as well.
That's pretty cool. And you started with logs, right?
We started with logs, and we are now beta and traces, and we're going to start working on metrics now as well.
High cardinality in metrics is a really big problem for a lot of vendors, right? Then if you tackle that, that could tremendously reduce cost for customers.
Yeah, exactly. So that's kind of the question for metrics is always like, do you actually need all the metrics? The problem is, yes, you need them when you actually have a problem, because you need to kind of dig down into the finest granularity you can to figure out where things are going wrong, but you don't need it all the time. And so if we're able to understand when metrics are needed ahead of time in the stream, then we can make decisions on when to send fine granularity metrics versus when to send coarse grain metrics. And that's
I really like the approach of reducing the data and also kind of creating more signal than noise, right? I always, when I talk to customers, I try to do this easy kind of analogy to finding the needle in the haystack, right? And what I'm trying to say is if the haystack is bigger, it doesn't make it easier to find the needle, right? Because I also see a trend in this market right now with bring your own cloud and those things that vendors try to make storing data cheaper, but that for me, it doesn't really solve the core problem, right? Of the noise problem. So even if you can store more data, it doesn't really make sense, right?
Yeah.
Because it doesn't help you in troubleshooting, or it doesn't make the database faster if you have more data. It slows everything down.
Yeah, exactly. And it's always like, well, how do you actually figure out what's important, what's not, and how do you determine in real time what is actually useful to be able to kind of just pass through the needles and kind of keep the hay on the side? But that is a very difficult problem, and that's kind of what we're tackling. But I've been thinking about this a lot over the past few days. You've seen what Anthropic has recently announced with the security tools, and then before that with the workspace stuff that they've built out. one of the things that I've been thinking about a lot is what does this mean for all this AI SRE work that people are doing? And how does one differentiate in that market, in that space? And where do the vendors like Anthropic and maybe OpenAI in the future and so on play? And how does that kind of over time play out? I'm curious about your thoughts on that. I have my own, but I'd love to hear how you think about it.
Yeah, I mean, first of all, my thoughts are changing all the time, right?
Okay.
Because the market is changing so quickly. But actually, yesterday I read the statement by the Google CEO who said that all the LLM wrappers will essentially go away over the next 12, 24 months. And only those who really own the data will survive, right? And that's kind of what I really thought from the beginning, that it is really hard. If you are an AI SRE tool and you are essentially your play is I do integrations and then I use an LLM to look at the data I get from those integrations. I think it will be first, I don't see a real mode because integrations also get very easy with coding agents, right? I mean, you see it with ourselves. If we do a new integration these days, it takes you a day because actually that works pretty well with coding agents, right? And so I don't think your mode is integrations. And then if everybody is using Claude, then also the result will not be so different. It will only be different if you own the tools, if you own the data, if you own the context, right? And then, so in my point of view, it will be very hard for these AI SRE vendors. At the moment, it's about speed, right? So they were fast. It's very interesting. There's value, but over time, I see it will be very hard to defend your price, etc. If you are just a wrapper around the LLM and if you don't own the data. So I do think there are fundamentally three, that's how we see it at the moment, three challenges. One is like the classical observability backend, right? You will still need it. I think you will need to store metrics, logs, traces in some form. You need to have some tools above it, query languages, analytics, these things, baselines and stuff like that. And then you will need something like Grepr. I really think you have to reduce the amount of data. We are seeing customers now, as you said, right? It's just crazy how much data they have, telemetry data, and how much telemetry data they are sending to the vendor. And I think you need to reduce that data and you need to do that intelligently. Like just saying, I keep 10%, that's not intelligent, right? And then the other thing is an agentic platform on top of it, where you will trigger workflows or other things like a new deployment. And then you will have agents that check if that deployment is working. And if not, probably will give back an analysis to the coding agent so that the coding agent can fix it and redeploy it. So I think there will be a lot of interaction between agents, from coding agent to production agents. So that's kind of how I see the world evolving at the moment.
It's not just I guess it's not this isn't just an an AI SRE problem. It's really a kind of an industry shift in terms of, well, there's all these companies that are building wrappers, like you said, around AI. And then how, if they were able to do it in 2 years or, whatever time it took them, imagine a company with the depth of understanding of LLMs and the volume of funding that they have trying to do it. And to a certain extent, there's actually an advantage to being later in the building of these capabilities as opposed to being early, because the technology is so new that you can actually learn from what other people are and eventually go and acquire those people. And so it'll be interesting to see how this whole landscape shapes up.
I agree. I think when Anthropic released the security agent feature, I think for me it makes sense, right? Because it runs on top of code and it checks dependencies for vulnerabilities, right? And I think that makes total sense. I'm not sure if they will move into production data, right? Because that's kind of distracting, I would say, for them at the moment, at least, right? But you never know.
Yeah, I mean, I don't know how much you've looked at kind of I think about what these AI SRE agents are doing and whether you can just build a whole set of skills as a plugin on top of Claude code and be done with it. And just open source that and have the rest of the world kind of just build on top of it. And it's just everything is available as MCPs, and whoever has the data can be queried and so on. So I'm curious, I keep thinking about that as like, well, how far can that go?
I definitely think that this kind of agent, the wrapper around the LLM, cannot be the mode. I
No,
don't think that this
no.
will be defendable. I totally agree. I think that will be commoditized pretty quickly.
Yeah. And I really, I think the way that you guys have handled it is really, really interesting, and how you've been able to actually enter this market and be able to really deliver something that's easy to start with, really uh, kind of captures what people have been thinking about in terms of the open source and being able to be free of all these vendors and really live in an open source world where it's like, well, just open telemetry. And if you don't like -0, you can go somewhere else because it's all OTel. We're not gonna limit you. But also being able to speak to the individuals, the engineers and the developers, and really hear and understand what they want, which I find really impressive.
No, and I do think we will compete on value. Also, if you are going into a customer, at the end of the day, you have to show that you reduce the cost, right? That's pure
Yeah,
value. If you can reduce data by 90% and you save 90% of your Datadog bill, that's super valuable on a cost perspective. But then you also have to show that the data that you are sending in this reduction really works, right? That you really get to the point that you get to the signals and you're not just reducing some noise, right? So I think that's what we will all have to face, right? I think people will have it easier with OpenTelemetry to switch tools, and they will have more choice, less lock-in. And that means we actually have to compete on value, right? Cost and value. I like it, right? It's more competitive. It gives us more options against the large vendors like a Datadog, right? But it also makes it harder, right? Because there will be a lot of new players trying to compete and innovate. So I actually like it. And as you said, right, I think you also need to tackle a hard problem, right? Because the problem Grepr is tackling is not easy, right? Looking at data on a stream and trying to figure out what to keep and what to aggregate and what to send to Datadog, it's a very tough problem, right? Especially on scale.
yeah. That's the biggest challenge. I mean, we've been building this for years now to solve that ability to actually figure out in real time what is signal and what is noise, what are the patterns in the data, and be able to extract it. And I'll say, like, one of the hardest things for us in order to solve this problem has been dealing with hotkeys, meaning somebody just sends a ton of data that all looks the same, that all is one log pattern or a few small log patterns. And this is what we actually always see. And when you look at log data, it's always, there's a few that are heavy hitters and a whole lot that are kind of, I guess, elephant and mice. And I think what people don't really, a lot of people don't really understand is that what is the difference between us, like this is the difference between us and Cribble, which is a tool like Cribble is just rules based. You go in, you configure the rules, you say something like, I want to handle these top 10, top 100. Maybe if you have a team of 10 people writing rules, top 500 rules. But what we do is actually we work on a million patterns at the same time in real time. We monitor all of these million patterns to understand which ones of them are actually noisy, which ones aren't, because what is actually noisy at what point in time changes over time. So today you've got these patterns that are noisy. Tomorrow a developer does a new deployment or an agent kicks off a new rev of the application, and all of a sudden all of your log patterns have changed. And now you have to go and refactor all that. And what we do is we just do it in real time, and we figure out, okay, here are all the patterns, here's what's new, here's what's different. And this ability to, in real time, understand what's new and what's old is what's going to really allow us to do some of the newer things that we want to do. This ability to understand what is anomalous in your application and what's new, what's novel, what needs to change, what needs to be monitored. And this is really how we are thinking about our AI future and how we want to do it.
How fast can you detect those changes? Is that immediate, or do you need a kind of learning period?
It depends on how you configure it. Usually to like the new patterns are immediate. So once a message comes in and it's a new pattern, we see that it doesn't fit in any of the patterns and we say, okay, this is a new pattern. And then Grepr basically works on a 2-minute cycle. So as the messages are coming in, We are looking at the messages and understanding what are the patterns in those messages. We slot them into existing patterns or create new patterns for them. So we pass through all that data. And then once we start seeing some of these patterns becoming noisy, that's when we start aggregating them. And then at the end of a 2-minute cycle, we'll say, okay, here's a summary for every pattern that we saw that we've aggregated. Here's how many messages we saw of this pattern, of that pattern. We can take some of these metrics, some of the metrics that may be in log messages and kind of aggregate them so you can have averages or sums and so on inside those summaries. And then we send that out to the downstream. And so when an engineer goes to troubleshoot or to see what's actually happening, they're looking at a few samples as well as summaries of what they've seen. And then the whole pattern, kind of the whole cycle repeats every 2 minutes. So you always get patterns, you always get samples as well as summaries every 2 minutes so that the whole system kind of continues to be dynamic over time.
Yeah. So as an example, I see some patterns with our customers that happen all the time, right? One is what we internally call burst. For example, a developer forgets to turn off debug level, deploys code, and you get millions of log messages in debug. So this is something you would then essentially detect, and you would see that's all similar stuff, and you will compact that and aggregate that so that essentially it will not hit my Datadog bill immediately, but you would get rid of it. Is that correct?
Exactly. So we can detect these kind of spikes that nobody else can. And this happens
Yes.
also for things like errors, right? So it's not just somebody forgot something, but there's a new error that occurs, and all of a sudden, everything is actually changing. There's new log patterns, new messages coming out. And so we can also detect all of those and aggregate them, make sure that at the end, what you're getting is really signal. It's not just noise and basically getting drowned in everything that's happening in your application.
Yeah, totally. I also remember when I still was programming and troubleshooting that I always, when I came to customers, you have these huge logs and there's a ton of errors in, and then you talk to the developers and they would tell you, yeah, but that's not a real error. And so you have these tons of errors, which are actually non-errors. And then it's really good to have this functionality where you detect that there's actually
A new
something
kind.
in there which is different. You want to focus on that because the rest is really noise, right? Because it's not a real error. It's just somehow an information message. So it's probably wrongly categorized, but I've seen it so many times that something was indicated as an error, but it's actually not.
Yeah, exactly. So like, can we actually in real time know when there's new errors that are appearing that you haven't seen before and be able to say, okay, these are things that we should be looking at. So that's the real power of what we do. And we do that in real time.
And without, as I understood, you do it without me configuring any rules or patterns or anything. You figure that out autonomously.
Correct. So Grepr is basically a bump in the wire, and we integrate with existing agents. So you can just point your existing agent to Grepr. You don't have to do a full deployment of new code. And then Grepr automatically figures out all the patterns in real time and does that compression. So it basically takes it from being something where you have a blank slate and you kind of have to go in and write every single rule yourself to something that's actually much more like tuning. And because we send all the raw data into a data lake, so none of the data is ever lost, you can always query it and bring it back. You basically have this risk-free, low-effort way of rolling Grepr out and being able to say, okay, out of the box it works and compresses 95%. When I actually need something, if it's not working exactly or the summary isn't exactly what I need, I can always go back to the data lake, bring it back, and then I can tune Grepr to make it do exactly what I need. And so this shifts that pain from the central platform team and pushes it down to the developers so that they can do whatever they need instead of kind of keeping all that work on the central team as well.
Maybe for logs, it's not a problem. But I was thinking how you do that if you do it for traces, how do you make sure that things like red metrics are still consistent in the tool, right? If you aggregate or remove things from a Datadog, as an example, and you would send only a fraction, like 5% of the data, then you are essentially not visible to Datadog, right? They wouldn't know that you have removed the data. So then the red metrics would be calculated wrong, right?
So specifically for Datadog, there's a separate metrics packet that basically gets sent because you can never actually send all the data from all of your infrastructure.
Yeah.
So no matter what, on the agent side, you're going to have to do some sampling. So they have to solve that problem. And they did solve that problem.
We also do that, right? Before sampling, we calculate the metrics separately. Yes.
Exactly. And then you send it separately. And so what we do is we basically, on our side, we do additional sampling and we recalculate those metrics and update them and send them forward. So that's how we solve that problem. But the thing that we do that's really unique on the tracing side is when you think about how people do sampling today, there's basically two modes. There's head sampling and tail sampling. In head sampling, you just basically randomly throw a dice and pick a trace to send forward or to drop, which is pretty simple. This is most of what people do. For tail sampling, you collect all the spans that constitute a single trace. You wait and you see, is it slow? Is it fast? Is it an error? And then you make a decision based on that, whether to send it or not. Now, the problem with this is that if you have different paths within your application that start at the same, let's say, at the same endpoint or the same operation name, then you end up with all these different trace paths that kind of fall into that same bucket of tail sampling. And what that ends up doing is that you kind of lose granularity. And when you're doing tail sampling at that point, then you're not actually really collecting all the traces that might be informational. And so what we do is similar to how we do logs. We figure out what are all the patterns, what are all the execution paths and all the traces in your system. And so that gives us a view and a picture of all execution paths in your application. And then we can do tail sampling because now we tail sample on the individual execution paths, which allows us to significantly increase sampling rates. So you could send 1% of the data and we can still guarantee that we're going to send you a sample of every trace, of every execution path in your application. And so that's really what's different about what we do, because similar to what we did before, we do it on the patterns.
To explain it a little bit from my point of view, right? I remember you have a lot of traces that, for example, start with /controller because there's a controller component, and then you have a parameter that decides an action, and based on that parameter, you did totally different things in the backend, right? And so what you are saying is if you, and mostly you decide what a trace is based on the path of the first span, and that would be controller. And if I do tail sampling on controller, I mix up all the different actions, right, that are inside. And so what you are doing, you are detecting the different paths for each of those actions automatically. And then you can do the tail sampling for each action, which will make the data more accurate, right?
Exactly.
That they do.
Exactly. But even more subtly, it might not actually be something that you can see in a parameter. It might just be that one path goes through a cache, one path doesn't go through a cache.
Yeah. So you really look at the structure, right?
The structure of the entire trace. Yeah.
Yeah. That's nice. Yeah, I mean, when we met in San Francisco, I was already seeing you. You also told me that you are still coding a lot, right? So you are totally into these algorithms and things. You studied at Stanford, right? So you're very deep into the theoretical algorithms of doing these things, right? Which is kind of hard problems to solve, especially on real-time data, right? It's tough. Yeah.
Yeah. I mean, I have the folks with me are some of the most brilliant people that I've worked with. I'm always so impressed with everything. Like I'm the type of, I'm fast and loose, basically. So I build stuff and I'm like, yeah, this should work. And very often, like the team that I have are the real people doing the hard work of really figuring out what it is how something should work, and they're coming up with the real algorithms and the real way. I just say ideas. They actually go and build it.
Yeah, I was similar. I was always joking. I had a good friend and we built our first company, and I'm more like, I don't read the README. I just get going. And so I was the fast one, but he was kind of like cleaning up behind me, right? I was going fast, and he was making it that it works, right? So we were a good team that way, right? Because sometimes you need people who just try things out, right, and don't overthink. But then if you need to run it on large scale and in different environments, then you need some more thoughts, right? And that's that's good. It was really fun talking to you. I think Grepr is one of the really upcoming interesting tools, right? Like a next gen intelligent Cribble, right? So I think it's will be super interesting to watch you.
Great chatting with you, Mirko, as always. Thanks for
Jad,
having me on
was very
on the
nice.
call.
Thank
All
you.
right. Take care.
Thanks for listening. I'm always sharing new insights and insider knowledge about observability on LinkedIn. You can follow me there for more. The podcast is produced by Datadog. We make observability easy for every developer.